Hi, everybody. My name's Dave Nettleton. I'm here to talk to you about Lakebase. So first of all, apologies for everybody who signed up for a different session, showed up to the room, and found there was magically a completely different named session when they got here. So that was, maybe surprise, surprise, intentional. As you probably saw, hopefully in the keynote today, we made some pretty big announcements around the operational database OLTP market that we're very excited about. And we didn't really want to leak that in the program beforehand, so we had to give it a slightly different, more obfuscated name. So thank you for signing up for that session. We're not doing that session. We'll be doing a session on Lakebase. So if anyone is incredibly disappointed, then please, I'll understand, but we'll be talking about something else today. So yeah, so Lakebase. So hopefully, who saw the keynote? Hopefully many of you saw what we are looking to do here. So I'll go through a little bit more background as to how we've been thinking about and why we're doing this, a new product category. I'll go through some more of the specific details about what we'll actually be delivering. So first of all, what drove the inspiration behind this project? Well, for many of us who've been working in the area of analytics and operational data systems, for years these have been very siloed, and there's just working between them has been quite complicated. But there's a big drive in the industry at the moment to sort of need to bring these use cases closer together. The time from insights from analytics needs to come down from sort of hours and days and weeks to be integrated with operational systems, so it's really quickly available. And the recent emergence of some of the AI technologies as well have really sort of driven the need to bring these two systems closer together. And I've talked to, so I've been at Databricks about a year and a half now. I've talked to a couple hundred customers over that time across pretty much all industries, a whole range of different use cases. This trend is consistent across all industries, across all use cases, whether it's for doing personalized recommendations or workload tracking of, say, clinical trial sign-off. We're just consistently seeing the need for having an operational database be close to the analytical data. Maybe I'll just go through a couple of super canonical examples that we see. This is probably the most common one. For customers who have data that has been curated in the analytical platform through the medallion architecture to get to a gold layer, quite often that data now needs to be served to an operational system. The days of that just being available for analysts who are working in the Databricks platform, plenty of use cases around that still, but very, very many of our customers are taking that data and they're moving it into an operational system so that they can serve that data, might be customer recommendations, product segmentation, directly in an operational system. And so what are some of the characteristics of that, right? It needs to be served, that data is in an application that's often, it might be a point of sale application, it might be a web application, but it needs super low latency, sub 10 millisecond latency, right? It needs to operate at super high QPS, thousands, tens of thousands of QPS. And we find that many of our customers originally would say, hey, I've had an analytical data platform for the last few years, but I now really need to think about building that and extending that to be an operational data platform. And for this, it's taking data from the Lakehouse, bringing it into an operational database, and then serving it out either directly to an application or often as features through feature and model serving. Second type of classic example here is application state. So that analytical data that exists, often someone will want to build an application around it that might do something like manage sign-offs for a workflow. So a good example here, clinical trials. A lot of data is coming from a clinical trial application, but there's a human workflow element that needs to sign off, reviewing that, handing it on to the next person in the chain. That's classic database capabilities. And if you then want to build that application today with Databricks, or I guess yesterday with Databricks, what did you have to do? You had to go find and provision your own database. You had to set up and manage it. You had to deal with a lot of sort of complex wiring just to get this very basic solution up and going. So these are two very common use cases. So now you've got an application, you want to store some application state around that, and then sometimes you want to then take that data and then also sync it back to the Lakehouse for analytics. And across those three use cases, those patterns, we often see people obviously combining them in all kinds of ways as well. But these are some of the most common things that we see. All right, so what challenges do customers have? So classic challenges I hear from lots of customers. It's really hard to provision. How do I get this database set up and integrated with my Lakehouse? Once I get it going, okay, data starts to flow. More data starts to flow. Custom pipelines that I built become brittle. Now I need to do 5, 10, 20 of these. How do I manage all of that scaling and complexity? And very quickly, rather than just providing data to applications, you're moving into basically the world of tending and caring for these systems. And then finally, automation. How can you do this quickly? How can you think of this much more like you think about development, where you can manipulate systems easily and think about staging and prod environments, right? And really reduce that sort of DevOps workflow. So these are super common challenges we see. So today we announced Lakebase, which is a fully managed Postgres database built for intelligent applications. 3 big parts to that: Postgres engine, separation of compute and storage, integration with the Lakehouse. I'll kind of go through each of these in a little bit more detail. So Postgres. First of all, why Postgres? Actually, raise your hands. Who is familiar with Postgres and is already using it in their organization? Okay, that's pretty much everybody, right? And this chart really shows it, right? Over the last decade or so, Postgres has really emerged as sort of the, if not the de facto, a standard in very, very many organizations, right? First of all, it's just a really great OLTP engine. Low latency, high performance, has all of the full semantics you'd expect around an OLTP engine, full ACID transactions, indexes, views, common table expressions, triggers, stoppers, all of the normal goodies you'd expect around an OLTP database. But a couple of things that also really set it apart is the rich ecosystem of extensions around it. Right? There's a great community building extensions around for geospatial, for example, or embeddings with PG Vector. And as well as the extensions, there's a really great ecosystem of tools, drivers, et cetera. So it's already a database that is hopefully very familiar to you and also the application teams who are in your organization. Because very often this sort of interesting interface between the analytical team and the application team or the DBA team, like how do they talk to each other? And often data just disappears over some pipe, and that's kind of it, right? And now, with a Postgres database engine, that's going to be a very sort of familiar lingua franca for people. So separation of compute and storage. So Reynold and Nikita did, I think, a great job talking about this in the keynote. And what this really enables is some very, very cool things. So traditional database engine, storage, and compute are very tightly coupled together. There has been some innovation on this to do some separation of compute and storage that some of the cloud vendors have shipped. They've sort of taken it to one step of separation of compute and storage. Inside, it's still kind of quite kind of locked up in the sort of the vertical stack. We've taken it a layer further and really separated out, storage ultimately landing in object storage, right? So data is landing into object storage, but we've built some very sophisticated layers in between the Safekeeper and the page servers, if you want to kind of go read up on that a little bit, of the technologies that lets us write data very quickly, serve it very fast, but do that in a way that can serve data to, so data is stored and managed regionally, which means now that when compute spins up, we spin compute up in different zones, and it can spin up and come down pretty quick, which makes for very powerful decoupled compute and storage. So with Lakebase, you can scale storage dynamically, you can scale compute up, you can scale it down. What we're launching in public preview today is what we would call a sort of a provisioned capacity model. So when you provision compute, you'll provision a particular size of compute. You can manually scale it up, you can manually scale it down, and you can turn it off if you want, and then bring it back up again later. So you do get those capabilities to sort of manage the costs. This is all running inside of Databricks infrastructure. So the compute and the storage is inside of Databricks. It's not in your accounts. It's not in your compute accounts. It's not in your storage accounts. It's in Databricks infrastructure. So we're sort of managing that stack end to end. We've added some great capabilities because we have this disaggregated compute and storage to handle high availability and fast recovery. As I mentioned, storage is regional. Compute spins up in a particular zone. Very easily, though, you can enable high availability, which will spin up another compute instance in another zone, making that available if there's a zone failure, for example, or some error in the compute stack. We can very quickly fail over to the secondary. We also optionally let you read from those secondaries. So a very common pattern is drive all write traffic to one endpoint where you connect to and send all your write traffic, and you can offload all of your read traffic into scaled out secondaries. So super common pattern to really help sort of manage performance and scaling. We've also enabled something called point-in-time recovery, and this is, again, one of those amazing capabilities that we have from Neon's technology. So Lakebase is all built on Neon technology today. We announced the acquisition, just like a month or so ago. We've been working together for, long before that. And the really cool thing here is, if you want to branch a database, say you wanted to have a test, you've got a production environment and you want to have a test environment. To do that is incredibly painful in traditional databases, right? It's often, you actually have to physically copy schema, you have to physically copy data, set up a dedicated environment, work with it there, care for it, trend it, manage it, shut it down. The really nice thing here is we leverage something called copy on write cloning. So we can instantly take that development, that production system, we can instantly clone it at the storage layer and spin up a dedicated separate compute instance where you can size it at a smaller size. So you might have a really big compute instance running for production. You can spin up a small test environment using the full copy of the data. It's completely isolated. You can work with it for test purposes and then shut it down when you're finished without impacting your production environment at all. But you can create these things in seconds, which is very, very cool and really helps productivity. So all of this is running in Databricks infrastructure. So we've integrated with Databricks identity and authentication. We've integrated with network security features like private link and IP ACLs. And then built in around normal other goodies that you want, like how do I do cost attribution and modeling. So we have billing tags for that, Terraform, asset bundles, et cetera. And then we've also integrated with, hopefully you also saw in the keynote, Databricks apps. So Databricks apps, very many people who build applications at Databricks apps want a database that they can use with that. And so we've integrated with them as a dedicated resource provider also. Integrated with the Lakehouse. So this has been something we've spent quite some time working through. So this is a full Postgres database, right? And obviously we want to make sure it works super, super well with the Lakehouse. And one of the first things, if you remember those use cases that I was talking through earlier, the most common use case is data is sitting in Delta and wants to be served to an application. So just as a reminder, right, data when it's in Delta is in the Lakehouse, it's either in Delta or iceberg formats most commonly. That's a columnar storage format. The data is laid out to make it really optimized for aggregations and scans and large queries, often covering terabytes and even petabytes of data. The data in an OLTP system is optimized for a different purpose. It's optimized for very low latency, high QPS read-write. So it has a very different format. It's a row-based format. So in the first we're going to go on a long journey here as we build this product line out. In our first version, we made it super easy to basically sync or copy data from the Lakehouse and into Postgres. So that's part of the public preview. We also have a private preview to go the other way, so just to go from Postgres to the Lakehouse. And what this does is it makes it really easy to go into Unity Catalog, just with a very few clicks, pick a table, for example, a Delta table. From that, you can create what we call a sync table. And then pick a few options. Holly demoed this super nicely in the keynote. You can pick a few options, click go, and you have a couple of choices on the type of synchronization you want to do. You might want to do a one-off, just batch copy, one and done. It'll physically copy everything over. You might want to set it triggered so that data triggers changes on a certain schedule or when you want to initiate the update, or continuous. And continuous is particularly interesting because you can be now writing data continuously in on the Delta side, and then we, through a pipeline, are picking that data up, and we'll be moving it over into Postgres. So you can write into Delta, we pick up that data, and then we sync it across continuously over into Postgres. And then once it's there, you can then use that for very fast, high QPS, low latency serving either directly to an application, or we've also integrated with feature and model serving, which is a super cool feature as well, where you might have the offline features for training in Delta. So that table that I talked about at the start could be classically, for example, a feature table. It has all of your training data in. But when you actually wanting to use that in production, you want to use the same feature spec, but you want to do much faster lookups for it as part of your solution. So we tie in nicely with that. So some other integrations, I think, so Unity Catalog. So we wanted to make sure that we had a really great Postgres database, but we also wanted to make sure it has really nice integrations into Unity Catalog. So you can operate and use Postgres database just exactly as a Postgres database, right? We wanted to make sure we had that full ecosystem benefit of the Postgres ecosystem, so we didn't really want to compromise on that. But we also wanted to make sure that if from an analytics world you wanted to operate with it in a consistent way, using Unity Catalog, permissioning model, et cetera, you can take a database that's in Postgres, you can register it into Unity Catalog, and then for anyone who's operating in the sort of the Unity Catalog world, we'll use Lakehouse Federation to manage permissioning and connections and querying to the database so that it respects the UC permissions model. Under the covers, this is using Lakehouse Federation. So this is kind of where we're starting with this. I think over time, we'll be able to build some really nice things that actually brings the operational data and the analytical data even closer together. Today, you're still dealing with effectively two tables across two systems. We'll slowly, as we started to talk about in the keynote, build tighter integration between those. Ideally, having both of the query engines able to operate over both formats through a common definition of a table, respecting a consistent Unity Catalog authorization model, right? So there's lots of interesting things I think that we can do here that the architecture innovation that we have will enable. We're starting out with a fairly straightforward, bring data from Delta into Postgres and serve super fast. We've also, as Holly also showed in the demo, is extended the query editor that is in the Databricks user experience today so that you can connect to that Postgres database. So the way the database shows up is if you go, there's a new compute type. So first of all, turn on the public preview. It's publicly available. So go into your workspace settings, turn on the public preview. When you then go to the compute tab, you'll be able to select, you'll see a new type of compute called the database instance. You can create a database instance there. That will give you a full Postgres database. You can then just click a button to new query it. That'll jump you out to a new to the editor, which now has a Postgres native version. So you can connect directly to the Postgres database. You can run normal Postgres SQL. You can browse the Postgres schema and interact with it right there in the console. You can also, of course, use all of your favorite Postgres tools, if it's pSQL, DBWeaver, whatever, to connect to the database that way as well. Pricing, quick word on pricing. So how have we structured pricing for this? So we wanted to keep it really simple. It's a database, so there's two main parts, the storage and the compute. Storage, we have a price per GB per month. This is super high, the reason we're able to do sub 10 millisecond, tens of thousands of QPS is it's very high performance storage. So we cache in disk and in memory a lot of the data in order to be able to serve queries as quickly as possible. So storage pricing is around about, it depends on region, depends on SKU, is around sort of the mid 30 cents per GB per month. So very different than object storage pricing, right, which is often 2 to 3 cents. Right? This is high performance block storage pricing for a database. So that's storage. And then for compute, we've made the compute, as I mentioned earlier, it's a provisioned capacity model for our first iteration. And the capacity there is sized up in what we call capacity units. One capacity unit is about 16 GB of memory. And then they go up there. So we have 1, 2, 4, and 8 in terms of capacity units which scale linearly. We're kind of giving a sizing in terms of GB, as we find that's often the most helpful thing for customers to understand performance profiles, because the more you can cache, the faster and more consistent your performance will be. And then the final component, which is optional, if you want to sync data between the Lakehouse and Lakebase or the other way around, we use DLT pipelines to do that. These are just normal DLT pipelines. They show up as DLT pipelines that you can monitor and interact with to a degree. We're running them and managing them, so but we do give a certain amount of observability. And so we charge just normal DLT pricing for when those are being used. So where to use Lakebase today? So I talked a little bit about some of the classic examples of the use case. So just straight up building applications, right? So you can use this just to build an application directly on Databricks today. It is a fully managed Postgres database. You can use it directly. You can also serve, as I mentioned, data and features from the Lakehouse through this. Offload, those queries that, someone has started to use DB-SQL in a way that it's not really intended, and you're kind of scratching your head as like, what am I going to do when the query is taking a second or two and I can't get quite the QPS that I want. Now we've made it super easy to provide support for an alternative for that. And then, of course, any data that you have in your application, you can bring back to the Lakehouse. So you might have an order processing application that's been built off of the Lakebase, and you want to take those orders and sync them back over to the Lakehouse for historical analysis. All right, one of my favorite parts of the talk is to remind everybody what this is not, because this is an OLTP database, right? It is not a replacement for DB-SQL. It is not a HTAP system. It's a classic OLTP database. That has a very different set of characteristics than a data warehouse. There are some overlaps on use cases, but they're pretty distinct systems. For anyone who's been using one of the early versions of this technology we had called online tables, actually, quick show of hands who's aware of or has been using online tables. All right, I could maybe do 10, 12 people. Okay, so online table, this was sort of our first version of sort of experimenting with this area. It provides a key value store, and it's super, super easy to use, but with that, there's a set of limitations. There's no capacity controls. It's read-only. You can't do richer querying against it. So what we're recommending everybody to do now, if you're using online tables, is to move over to using Lakebase and sync tables. Lakebase is a superset of that functionality. So we're really recommending everybody to start to move over now that we're in public preview. And also just a reminder, if you're using other database systems, Oracle, SQL Server, the list is very long. Just a reminder that this isn't always like moving from one database platform to another. It's sometimes a non-trivial task. The languages are different. The ecosystem around them are different. So while I think there are lots of opportunities to bring databases in, we don't have any tooling to support or help with that at the moment. So just be aware if you want to bring an application over that there's an element of sort of manual migration work to do that. So we've been in private preview for a while now. We've had some great customers who we've been working with. I put a couple of examples up here of quotes from those. Heineken, this was a great example of one of those customers who, the conversation just still stays in my mind where, we're sitting down and the team is saying, I have built this analytical platform, but the needs of my business are changing. Like the operational and transactional systems are needing to come together because I need to serve data now in real time to a much broader audience, not only of humans, but of applications. I'm now building an operational data platform. My team is no longer an analytical data platform. It now has to become an operational data platform. So classic example there also, with Tibber, really great to see them leveraging these capabilities, again, to serve insights at really high speed. A lot of other customers have started to use the product. We've been getting great feedback over the last several months on this. Also super pleased to have a really great set of launch partners, both system integrators as well as technology partners. Hopefully many of these you're already used to working with. This is also one of the wonderful benefits of using and offering a Postgres database. As I often say to people, they're like, so what's the database? I'm like, it is just Postgres, right? It's Postgres. So you can use it as Postgres. You can connect to it as Postgres. You can integrate it just like Postgres with very many of the technology partners, whether that's for data integration, BI, governance, et cetera, et cetera. So very pleased to have a great set of launch partners with us. And I'll take a second here because I've talked a bit about what we have today, right? So we have a fully managed Postgres database. It's based on provisioned capacity. It's super well integrated with the Lakehouse. We've taken advantage of some of the really nice architectural layering so that we can deliver high availability. We can also provide point-in-time recovery. I didn't spend too much actually talking about that, but this is the ability to very quickly take that production instance, right, and branch it into a test environment. It can be used for tests, but it's also used for point-in-time recovery operations. So if someone accidentally deletes a table, you can point a copy of the database now back in time. So we allow you to set a recovery window of up to 35 days. You can just point back in time, instantly create a branch. Remember, we have that instant branching copy on write capability. So I can create an instant branch off of that data. I can spin up dedicated compute on that. That table that was deleted, I can very quickly select star from table, drop it out to CSV, go to my other instance, bring it in, and within minutes, kind of recovered data that I potentially have dropped and need to get back. Now, doing that in older systems, you have to go back to backups or snapshots. You have to do a full recovery process. You have to bring it up side by side into new infrastructure. Then you got to go through the process that I just described. So the actual just getting to the point when you can start to recover can take sometimes hours. If that was a big database, you're talking hours to recover the data back. If this is a big database, branching is still instant, regardless of the size of the database. So super, super powerful. So really excited about the set of capabilities we have today. There's a whole extra set of things that we're working on now. One of the pillars that we talked about in the keynote was the sort of the built for modern DevX. Two super important parts for that. That we'll start to expose in the product. Sort of the branching capabilities we have at the moment, we've made it we wanted to focus on like a couple of key scenarios to make it super simple. So you can take one of these database instances, and then you can create a child instance off of that. That's effectively branching under the covers, sizing the compute capacity separately. What we want to do is go beyond that, right? So we want to enable full branching capability, so you can create many branches very quickly, branches of branches, et cetera, right? Sort of the full branching hierarchy. Think of it as like a tree with a root and then many branches coming down from that. And then we also want to, the capacity model we have at the moment is a provisioned capacity model. So when you spin up compute, it takes a minute or two for the compute to spin up. We want to get to the point where we have instant provisioning and auto-scaling of compute. And then once you have that combination of fast provisioning of compute and instant branching, that now means that developer loop, that developer experience that we talked about, is now just sort of unlocks an entire new set of use cases, particularly around developer journeys, and also, as you heard a lot about in the keynote, AI agents that want to take advantage of that super fast iterative loop that is not dealing with a large monolithical database with giant data copies and capacity that you can't use that you can only use in a very particular way. So we're very excited about that. This is part of the, as I mentioned earlier, we acquired Neon just recently, and this will be part of our work with them now as we look to bring more of that experience together. Actually, show of hands, has any of you used Neon just outside of Databricks? Okay, one. Okay, this is another killer. Like, just go try neon.com, right? It's a super cool product. You can use it to sort of vibe code an entire application through Replit, Lovable, other tools. Really easy to build databases, right? So this is really built applications that are running on databases. There's going to be, this is going to happen a lot more. And we're really excited about providing a platform and an infrastructure to support that. So get started today. We're in public preview. Very excited about that. We have 10 minutes and 20 seconds for Q&A. Well, thank you, everybody, for attending the session that changed its title at the last minute. Please try it out and give us feedback. Thank you.